So in part one, this idea of the conditional statement was introduced to you by me, and by the course outline, you knew it was coming. We broke those words down. Statement just means something you say, and obviously the way we say things is in code. So it's a line of code that follows a condition, okay? And the condition essentially acts as a gate to determine whether you get in or not, okay? The basic structure of the conditional statement is the keyword if, okay? It's a keyword. It'll appear in blue in your code, always typed in lowercase. Then you have two sets of brackets. The round brackets contain within it a test that will give you a true or false answer. So in a lot of ways, an if statement's like asking a question. If this is true, what should I do? And then the other part of the if statement is controlled by the curly brackets. The curly brackets create a structure that essentially use the gate to determine whether or not you get into this structure or not, okay? That's the basic structure of what we've done so far. And you've been able to look at least, if not solve, two programming problems that just involved either just this if or this if combined with its partner, the else. Now else doesn't need to test anything because it just matches up with the if. It says, well, if this is true, you get in here, but if it's false, I have a different structure for you to get into, okay? So this is the structure you get into when the test is true, and this would be the structure you get into if the test is false. And else is optional. You didn't have to put the else there. You could have just written the if without the else. Okay, so hang on, let me put that together for you. Group it up and shrink it down. And then this guy, group that up, shrink it down. So you could put the else with the if, or not. You could just have the else on its, or the if on its own, okay? Or you could slip an else in there depending on whether you needed it to be gating whether it's true and false, or just checked if something's true or not, okay? So it adds a whole new sort of level to your logic in terms of the way you can program stuff. And that's what I want to sort of go over with you guys today, is that same idea. Okay. So this idea of the conditional statements controls now the way your program runs. It no longer has to run one line after another. Now you can determine whether or not pieces of code will run or not. It gives you a gate or a condition or a sort of direction to your code. But what if we have multiple conditions? Okay? So what I'm going to do is, I'm not going to have you guys do this example. I'm just going to show it to you, and it's in the notes as well. But let's say I had this little program where users would enter their grade as a number. And then determining that grade, I would give them a letter grade, right? The traditional A, B, C, D, etc. So I might code it something like this, okay? Well, first thing, I would get the text out of the text box, okay? And then convert it into a number. Now, I can get a little bit fancier now at this point, since you guys have done that so many times. I wouldn't recommend this necessarily, but I could basically get their grade by automatically converting to an integer what's in my text box, and I don't believe I even named it, textbox1.text. Okay? This is me sort of taking an extra step. Now, again, I wouldn't necessarily recommend you code this way, but some of you have seen this kind of stuff before. Nonetheless, now I have that number. Whatever number they type in here, I have it. It's a value for me. So now I could apply an if statement. Okay? And I could apply an if statement to see kind of what's going to happen there. So I could say, well, if that grade is greater than or equal to 90, I'm going to say that this person got an A. So I'm going to use a message box dot show you get an A. Okay? And let's see how that would work. So I run it. I type in 90. and I hit enter, and yes, you get an A. Okay? Now, if my grade was 50, notice nothing happens because I don't pass the test. The grade is not greater than or equal to 90. The grade, which is 50, doesn't pass the test. But what if I wanted to do 80? Well, I could use the magical power of copy-paste here, and I could select all this code and copy it and paste it and say, well, you know what? If you get a grade that's greater than or equal to 80, then you'll get a B. Let's take out that extra space there. And then what if I did it again? And I said if it's greater than or equal to 70, you get a C. And then greater than or equal to 60, you get a D. And then greater than or equal to 50, I'm just going to say you pass. Maybe that shouldn't be in all caps because it's not that exciting. You pass, okay? And then I'll throw in the else right here. Oops. So if I don't get anything greater than 50, well, I must be in the 40s, the 30s, the 20s. Well, I'm sorry, you fail right there. You're done, okay? So this is me setting up sort of a structure for how to kind of get that to work, okay? So let's see what happens. If I enter 51, you pass. Looks good. Everything worked the way I thought it should. What about 20? You fail. So looks good. But let me go back to that 90, and actually I'll go to 95. What should happen? I should get an A, right? Let's see what happens. You get an A, and a B, and a C, and a D, and I pass. I get them all. And the reason why is because it passed this test. 95 passed that test. But you know what? 95 also passes this test. It's greater than 80. And it passes this test, and this test, and this test. It passed all those tests because they're each separate tests. Okay? They're separate tests that all tested individually. So this isn't quite the right structure. Okay? Shh, no typing. No typing. Should be listening. Everyone stare. Okay. So anybody have an idea? What could be a solution here? Well, what we need to do is we need to bring that else part in a little bit earlier. It's a little bit too late for the else statement to come in way at the end here. So maybe if I go back to the beginning here and I think, okay, if I think for that first test, if the grade is greater than or equal to 90, I get an A, then maybe I had the else. Okay? So now I'm down here in the else, but I have to test the next thing. I have to test this. So what if I took this code, cut it, and put it inside the else? That would be the start of maybe how it would work. And what you see happening right here is a concept in computer science called nesting. Okay? So let me jump for a second. And this, as I said, is in the notes right here. So here it is, the same code. And if I enter a 51, it says I passed. That's all good. But if I enter the 91, as you can see, all the boxes came up. So what we have here is what's called a nested statement. This is one of the solutions we're going to look at. Okay? To nest an if statement, it's not that. No, what you do when you nest an if statement is you place one if statement inside of the block of another if statement. And remember, what a block is the space in between the two curly brackets. So it would look like this. Okay? Now, let me go back to my example, and let's do what it says right there. So, okay, now, without going any further, let me test that, let me test 80. I'm going to run this. I'll test 80. I get a B. So it didn't say I got an A. But I still get a C, D, etc. I get the rest. What about 91? I get an A, and then it goes to C. So it didn't at least say I got a B. So it's kind of working, at least part of it. This part is now determining whether I get an A or a B. But now I have to see whether I get a B or a C. So I'm going to have to create another else statement in here. And inside that else, I'm going to have to put this if statement. So that if statement has to go in here. But wait, now I have to determine whether I'm getting a C or a D. So inside of there, I'm going to have to put another else statement. And inside that else statement, I'm going to put this if statement. And it's going to go in there. If you're thinking a bit confused right now, you're probably right. Oh, and wait, I need another else statement right here. And inside that else statement, I'm going to have to put this if and its else. So I'm going to take all of this and put it right in there. Now, I know you won't be able to read it, but let me back up here. This is what the code now looks like. And all the indenting that takes place. Remember, when you're inside an if statement, you indent once, and the code usually does that for you. Now I'm inside of an else statement, which is indented. And indented again. And then in here, indented again. And then again, and then again, and then again. When I get to this one, it's like 5 indents are happening there. But you know what? This logic structure might actually work. Let's see. I'll enter a 50. I pass, and that's it. Now I'm going to enter 91. I get an A, and that's it. Oh, that's what's supposed to happen. How about a 75? I get a C. And notice no other boxes appear. So I've created the right structure here. And look at all that crazy indenting though. So now, before you start panicking and I don't know what, like doing something that's horribly stressful, this is how it works. If this is true up here, if the grade is greater than 90, just like any other if statement, if the if part is true, then the whole else statement doesn't execute. So everything that's inside that else, which is this huge block of code, it doesn't run. The only thing that would run is the if statement. Now, what if that was false right there, like a grade like 80? So now it drops into the else statement, and we have yet another if statement. And if that if statement is true, it executes that line of code, but not everything inside of its block. So it's these giant blocks of code, execute or don't execute based on the gates, but it's super tricky. So knowing this, we found an easier way to write code like this. So the good news is what I just showed you is not something you have to code. What we can do is combine the words else and if together into what's called an else if statement. Now let me show you how this works. And it's in the notes as well. So what I do right here is notice how this else is followed immediately by an if statement. Well, why couldn't I just do that? Instead of putting a whole bracket there, what if I just separated them with one space? That would work. Similarly, this else is separated but immediately follows with an if. So I could just put a space. And this else, and this else, and then that else is all on its own. So now I'm going to have to backdent these, not indent, but backdent some of these. Oops. To fix up my indenting that was all kind of messed up. Okay, and let me, actually I should have started at the beginning here. Whoops, that goes back. And that one goes back. Oops, too far. That one goes back. How do I do that? You hold shift when you press tab. And it goes backwards. And then I have a bunch of extra brackets now that I don't need anymore. I'll get rid of those. And this is why I wouldn't have not taught you that way. This is now the code. Let me pull back. That looks a little better. That does the same thing as the code we had before. It looks a lot cleaner. It kind of almost sounds like the way we talk. Not exactly. But let's say you had 10 things you could do tonight. You could say, well, if we have enough money, let's go to the movie. Otherwise, if we don't have enough money, we could do this. Otherwise, if I use the word else instead of otherwise, I know we don't normally talk like that, but if I said, well, if we have enough money, let's go to the movies. Else, if we don't have enough money, let's go to this. Else, if we don't have enough money, let's do this. It's kind of like how we talk, and now it's kind of like how you're going to code. If it's this, do this. Else, if it's this, do this. Else, if it's this, do this. It's a series of multiple tests now that you can perform all at once, and it should still work the same way. Okay? So this is called the else if statement. Here it is in the notes again. What it does is it goes through each test and it finds the one that is correct. So for example, if the grade is 70, it'll find that this test is correct. So it'll say it fails this test, fails this test. Oh, this test is correct. So it'll run only that line of code and then leave all the rest of them. Doesn't execute any of the other lines. So it's like a series of doors. It picks the one that's appropriate. Now, just like a regular if statement, at the end, you can, if you want, add a else at the end. Now that else is just the general else, which means if this is true, do that one, or do this 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 one. But if it fails all the tests above it, then just do this one at the end. So that's for if I fail every other test. But that else at the end is optional. Okay, now, for those of you who are feeling a little more adventurous with your coding, for those of you who are still learning this and are still not confident, I would never recommend this. But here's one little subtle thing that you can also do in your code. Okay? If a line of code inside of a block, and remember a block is the code between two curly brackets. So this is a block right here. If the line of code inside there is only one line, which in this case it is. As I said, I could put like 10 lines, 10 million lines in there, but if it's only one line, then the curly brackets are actually optional. And again, I would not recommend this, but I could, because that's only one line, actually take those brackets out. And to save space, I could even do that. Now this is also one line, so I could kind of do a little bit of editing here, a little bit of code edit here. Hang on, follow with me. This is also one line. There we go. Now that looks even maybe a little bit easier to digest. Now, the structure is still there because it's only one line. The chances of you writing this and maybe getting an error might be a bit higher because you got to be careful how you write it, but it's a little bit cleaner looking. So only for those who are feeling confident enough to try this would I actually recommend it. Because you might actually screw up your code without using those brackets. You can still use them. The brackets, removing the brackets is optional. So as you can see there, you save some space. It might look a little bit cleaner, but you might get an error. Now there's even one more thing you can do. If it's only one line of code and you don't have brackets, you can actually move the code up to the same line as the if statement, like this. So in other words, I could write code. Let's put a little extra space in there just to make it look pretty. I could write code like that. And that does the exact same thing as you remember back that giant set of indents? Exact same code. Works exactly the same. But you got to be confident in writing code to do this. If you're still learning if statements, no way would I ever recommend this. And there's no preference. Some programmers like to do it this way, some others, some do a variation here and there. Just be careful in writing it. But that is still fine. Okay? And again, I'd only recommend that for those who are feeling adventurous enough to try it. But that does the exact same thing. And that's also in the notes. You can see this right here. It says, not at all recommended, but if it's only one line, you don't need the curly brackets. As well, you can actually move it up to the same line. So here you see that code as well. Okay? Exact same code. Okay, that's actually it for if statements. That's all the only other thing I wanted to show you about conditional statements. But now I want to show you one other thing because I know your programs are going to want to get a little more interesting, and I know eventually some of you are going to want to make some games. It's a hint, or sorry, it's a hunch, but I think you're going to probably want to make some games. And if you're going to want to make games, you're going to need, not going to have to, you will have to know how to do this. You have to make random numbers. That's what makes games interesting. If they're super predictable, you don't play them, right? Only when it has that aspect of randomness to it does it actually make it more interesting as a game. And the randomness all comes from numbers. So we're going to start by generating some random numbers, okay? So games, simulators, screensavers, all kinds of stuff require random numbers. In C#, random numbers are generated through what's called a built-in function. Now, any of you who are taking a certain level of math this year have heard that word before in a math context, okay? But that also applies to computer science. Not so much this year, but more so next year, okay? It generates a random number between 0 and some maximum. So I can say, give me a random number between like 0 and 100. It'll give me that, okay? So, in a sec, by the way, this will be in the example we're going to do today, so I'm not going to key this in. Here in this piece of code, it shows how to generate a random number, the basic of it. So the way you do it is you're going to use this line here, and I'm not going to over-explain this line to you. You say, and it is a weird line to write, random random equals new random. It's super easy to remember, but there's some important things to note about that line. I don't know if you can see from here. The first version of the word random uses a capital R. The second version of the word random uses a lowercase r. And then the third, again, a capital R. In the grade 10 course, that's not a big deal to understand, but it actually is a big deal in terms of why it does it that way. So random random equals new random. And then I generate a number by saying lowercase random dot next. And what next does is it says, give me the next random number you want to generate, computer. And then I output it, and there it is. So it was 677026004. That's a random number. And if I click that button, it would generate a different random number. Okay? So it will generate a random number between 0 and as large as an integer can make, which is like 3 billion. So that's the random number it came up with. Okay? Well, that's not always useful to you. Like if you're making a game with dice, you don't need some 3 billion number. You need a random number between 1 and 6, not 3 billion. So what you want to do is change this around a little bit so that it fits within a range. Okay? Here you see an example of that. What you then do is add a little bit here to the way that line works to add sort of values to it to generate it within a range. And we're going to do this in the example today. Okay? Now you notice the random number being generated is 88. That's more useful. It's between 10 and 100. That's better. Okay? So it's between a low value and a high value. Okay? So this will be useful for all kinds of things like games. Like if you're making a little character and it was going to go one of 4 directions, you could generate a random number between 1 and 4 and then head it off in one of 4 possible directions, or maybe 8 possible directions, or 360 directions if it was going all around a circle, right? You can also generate random doubles if you needed a random integer, double value. That's a little more rare. I doubt you were going to do that. But as well, for some of you who really want to dig deep into this, there's actually a formula for specifically generating random numbers inside of specific ranges. That's kind of general to most programming languages. And there's an example in the notes of this right here, but we're not going to code this example. But the example's there where it generates a random number, or in this case a random double, in a specific range. But you have to use a formula for that. Okay? All right. The one other thing that we're going to do in today's example is this piece of code. Some of you have already kind of used this a little bit. There's a piece of code called form load. And what it is the code that executes when your program first appears. Let me demonstrate that on the little demo that I got running right now. So here's my design. To access the code called form load, you double-click the form. And there it is, form load. And here I can put whatever I want. So I'm just going to put a little message box here. Hi. Now watch this. When I now run this program, I'm going to run it, that message box appears before the form appears. So it's automatically running this code before the form even appears to you, before it loads up into your game or whatever it is you're creating. Okay? So that's the piece of code called form load. We're going to do that in today's example, so I just wanted to show you what it was. Okay. Now, this last piece I want to show you before the example is optional. You don't have to use this to solve any of the problems in this unit. But I can tell you right now, it will help. It's a little tricky to grasp for some of you, but it's a way to combine logic together. Now, it does make natural sense when you start thinking about it, but when you apply it to code, it is very kind of cryptic. It looks different. So in C#, you have these things called the logical operators, and you create a Boolean expression, which means it becomes either true or false. But sometimes you want to join these things together. And you can join them using 3 logical connectors, the words and, or, and not. By the way, these are also built into Google search engine, but I can show you that on a different day. Okay. In C#, the way you write these is using these strange symbols to represent the three things. And is two ampersand symbols together. Or is two vertical lines. The name for this, by the way, is the pipe symbol. These two pipe symbols connected together. And then not is an exclamation point. And you already knew that because not equals uses an exclamation point. Okay. Now, this is an extremely confusing sentence, but let me read it to you. When the logical expression and is used, the overall expression evaluates the true if both the first and the second are true. The logical expression or is used when either the first expression or the second expression is true. So let me kind of put it into a chart. So using and, if I have two things together, if they're both true, then the whole thing is true with and. With or, either one of them could be true for it to be true. So maybe let me use an analogy. If apples and oranges are fruit, then they're both fruit. Both have to be fruit for that to be true. If apples or oranges are fruit, well, either one of them can be fruit. So like if I say if apples or dogs are fruit, is that true? No. Wait a minute, listen to me say it again. If apples or dogs are fruit, is that true? Yeah. Now let me re-sentence it. If apples and dogs, pardon me, if are fruit, is that true? No, because and requires both of them to be true. So it's tricky, okay? We are going to do this in the example today, so you'll have a piece of code to work from for this. And for sure, problem 4 of this unit, this would be really handy to use. You can do it without it, though. You don't have to use it. Okay, and then not just reverse things. Usually an if statement executes if something's true, but you can use not to just make it execute if it's false. But that, again, is very rare. Okay, here's what I need you guys to make. So you're going to make these 5 labels, 2 text boxes, and a button. Okay? The names for them are all here. All right, let's get crack-a-lackin'. Software. Okay, so here's my design. We just quickly check. Yep, everything is named for me. So I'm ready to code. Okay? So obviously the only thing we're going to code is the button. So let's go into the code for the guess button. Okay? Now, before we code the guess button, we're going to create a couple global variables. So we're going to go up in our code under the words public partial class. And again, when you go up here, make sure you make some space up here, but after that bracket. Don't put it before that bracket, okay? And we're going to create 3 global variables, 3 integers. An integer for the number of guesses. We'll start it off at 0. So that'll keep track of how many times we guess in this program. Starts at 0. And then 2 variables for the 2 numbers. Number 1, which will start at 0, and number 2, which will also start at 0. So those we need to remember for the whole program, right? Because the user is going to be guessing multiple times, so we need to always remember what our 2 numbers are and how many times they've guessed. So this is an instance where we're using global variables because we need them always to remember their value. Okay? So we'll start with that, those 3 global variables. Now, we actually need to code one other thing. We put code for the button, but what I need you guys to do is go back to your design, and I need you to double-click the form. Now be careful because you have labels all over the place, so you might accidentally try and double-click a label. So try and find an empty spot on your form, like somewhere in the deep corner, just outside the button, and double-click that. Because what you want to get is to the code that says form load. Now, if you named your form, like I did, if you named your form, then that name will be there, and then the word load. But if you didn't name your form, it'll just say form load, or form 1 load. But if you named it, the name will show up there. So yours might look a little different than mine. Okay, so here's what we're going to do. When this form loads up, let's generate the 2 random numbers. Okay, so here's how we do it. We say random random equals new random. Random random equals new random. That's the line that starts it off. This creates what's called a random number generator. That thing will now generate random numbers for us. Now, a couple quirks about this line of code. As I said before, this uses a capital R, this uses a capital R. This one does not use a capital R. As a matter of fact, this word here could be anything. It could be random x equals new random. I just like having everyone in the room type random, random equals new random. But second thing that's quirky is it again uses that keyword new there. Okay, again, I don't need to over-explain that. If you want way more detail on kind of what's going on there, take the grade 11 course. Although we will cover this in some detail at the end of this course. And then thirdly are these round brackets right there. We've seen those before on things like application.exit, on things like message box. What they essentially mean is this is a built-in function. Function? How many have heard that in math this year? Did it look something like this? Is that what it looked like? Did you make round brackets? Okay. What do your teachers call this? Don't say X. A variable. Yeah. Hey, we did a whole unit in variables. Anyone use a name other than variable? Any teachers? Oh, they're not being good enough yet. Actually, it's called a parameter. But again, we don't need to get into that. Moving away. All right. Now, let's deal with number one. Number one equals random dot next in a bracket. And it's weird how this works, but I'm going to put the number 0, 5. Why? That looks strange because I asked it for a number between 1 and 5. Okay? But the weird thing about this thing that generates random numbers is it always goes one more than the first one. So it's this strange 0, 5, not 1, 5. What would happen is it would generate sometimes, it would generate, if I put 1 to 5, it would never generate the 1. It would just be 2, 3, 4, 5 all the time. So now let's deal with number 2. Number 2 equals random.next. And with that one, I'll put 0, 3. So it generates a random number between 1 and 3. Okay? Okay, that's done. You don't have to put a space right there. It will probably put one for you if you let it finish the code for you, but that's entirely optional. Spaces are generally ignored in code, generally. There are exceptions to that. Right? Like right here, there's a space. I don't need a space. Or I can have 20 spaces. Doesn't really matter. Spaces are generally ignored by C#, but not always. Okay, so basically what happens is when this program first launches, it will have generated 2 numbers. Now, you don't need to put this in your code, so please don't. But I'm going to just show you what that looks like. Message box, again, please don't type this dot show. I'm going to say that number 1 equals, oops, number 1. Don't worry about what this is. Okay, so I'm just going to show you what the 2 numbers are. So I play this, and look at that. It says that it's a 4 and a 0. Whoops. You know what? I think I'm thinking of the wrong programming language. Let's switch those zeros back to 1s. Whoops. I may have screwed up. Of course, I do that intentionally to make sure that you guys are paying attention. All right, so let's try that again. There, 2 and a 2, and then it launches. And then we try it again. 4 and a 1. And I'll try it again. 2 and a 1. And 2 and a 2. So it's generating random numbers. So at least I know that it's working. Okay, sorry about the 0 thing. I was thinking of a different programming language. Okay, now let's go back to the code for the guess button. Okay, leave yourself some room because we're going to type a fair amount of code here. Okay, so we need to determine whether or not they got both the first and the second number in the whole running of this game. To do that, we're going to use a variable that you may not have used before, but we've talked about, the Boolean variable. The Boolean called first will be equal to false. We will assume they haven't got the first number, and the Boolean called second will also be false. These are two Boolean variables that will keep track, true or false, whether they got the first or the second number. It'll give you a red line right now just because we're not using them, but we will be. Okay? So the next thing we need is we need to get the guess. Int guess, oops, the guess from the user is converted to an integer from our text box, okay? The first text box dot text. Okay? So we're skipping a step here, like I showed you in that previous example. Rather than read it into a text variable first and then converting it, we're going to do both at once. We're going to say the guess is you take it from the text box, convert it to an integer, and that's the guess. Okay? So this is our guess. So we pulled in the guess that the user had. And now comes our if statement. Well, if that guess equals number 1, then that's important. They've got it. Remember, equals is a double equal sign. Okay? So if the guess is number 1, well then first equals true. We've marked that it is true. And our label, LBL first dot text, equals correct. We'll just say you got it. Okay? So we start off with that if. We check, hey, is this the number? If it is, then I'll just say correct. Now, you don't need to play yours. I'm just going to play mine to show you. I'm going to guess a 1. Nope. I'm going to guess a 2. Nope. I'm going to guess a 3. Nope. I'm going to guess a 4. 4, correct. So it was 4 that time. Okay? But that's not very helpful to our user, just doing that. So let's add to that if an else if. Okay? Now this time we're going to say if the guess is less than number 1. So if the guess is less than the number that then I'm just going to say into LBL first dot text, I'm going to say you guessed too low. Too low. Okay? That's too low. And since I'm doing this, I'm going to add another else if the guess is greater than number 1. You can probably guess what I'm going to say. LBL first dot text equals, that's too high. Goldilocks. So I've created a 3-part if statement here. If you get it, I'll say you got it correct. If it's less, I'll say it's too low. If it's greater, I'll tell you it's too high. As well, if I guess it, I will mark that I got the first one correct using a little Boolean variable that clicks on that it's true. Now, I'm just going to try this at this point, see how this runs. Again, it's only working with the first random numbers. So I'm going to guess 3. 3 was too high. Oh. So that lets me guess a little bit smarter now. I shouldn't guess 4 or 5 because 3 was already too high. So maybe I'll guess 2. 2 is too high. Well, guess what? I bet you it's 1. Yep, 1 was correct. Okay. Let me try it again. This time I'm going to guess 1. Oh, 1's too low. Let me guess 5. Oh, 5's too high. You get the idea, right? It seems to be working out nicely at this point. Okay? Now, what we're now going to do is basically do all of this over again. All this code's going to happen again, but with the second number and the second label. So if you're feeling like you can handle copy-paste, copy all of this Okay, notice everything I got highlighted. All the way up to int guess, copy all that code and paste it just underneath it. But then you're going to have to change it. If you're not feeling adventurous, then you should probably type it all. Okay, so the first thing we're going to have to change is guess has already been created, so we don't need to say int again. It was already created up here. So take the int part out there. Second thing we need to change, right here. It's not txt first, it's txt second. Okay, so the first changes were right there and at the front of that line right there. Okay? Nobody's freaking out yet? All right, now, this thing that says number 1 needs to be changed to number 2 in 3 places. So right here, here, and here, you change it to number 2. Keep in mind as well, this says second, and we got rid of the word int there. Okay? So far, so good. Now, the next changes we're going to make is all right here. Instead of LBL first, those 3 are going to be changed to LBL second. Okay? So you can go ahead and change those as well to LBL second. And thank goodness for copy paste. Made my life a little bit better. And then the last change we're going to make, does anyone know where it is? Anyone know the last change? Think about it for a sec. There's one more change we're going to make. Yes, ma'am. Press insert. Does anyone see what the one other change we have to make to this code? Oh, you all missed it. It's right here. Shouldn't be first equals true. Should be second equals true. Okay? Second equals true. Okay, now, let me see if it works. I'm going to guess a 3 and a 1. This one was too high, this one was too low. Oh, okay. So maybe I'll guess a 2 and a 2. I got it, correct and correct. Okay? But I got a few other things to deal with as well. Like this is so far working pretty good. Okay? But I want to add a little more features to this. But before I go any further, did anyone miss any piece of that? Okay, so let me get rid of a couple spaces here. You, again, do not have to. I'm just cleaning up a few extra spaces in the code. Okay, so now, continuing on, we're still inside that button. We're now going to determine whether they got both. So here's the way we're going to write this if statement. We're going to say if first equals true. Okay, so notice what I'm doing there is I'm using my Boolean variable. I'm saying, well, if they got the first half, now watch what I put next. And, that means and. What do you think it's going to follow it with? And second equals true. So that line of code basically means if the first half was guessed and the second half was guessed, well, then they got them both, right? If first is true and second is true, why? Let's congratulate our user with a little message box. Message box.show. You win. Or you're a winner, or whatever. I don't care. Okay? Now, that's pretty cool. But let's go a little further. Let's say else if. What's going on? There we go. Else if first equals true, or, not and, or second equals true. That means they have one of the two, but not both. Or they could have both. But if they have both, then the first message box would have already showed off that they win. But if they only get one of the two, then I'm going to also use a message box. And I just say, you got one. But as well, when they get one, I need to increase the number of guesses Guesses equals guesses plus 1. Okay? So I increase the number of guesses. And then finally, we also have the else. What is the else in this game? What does it mean in the else in this game? Well, what it means is, well, if they got both of them, then they win. If they got one of them, then they got one. The else would be they got neither, right? They didn't get either of them. They're bad. So we don't need to yell. We don't need to yell at them, but we should increase the number of guesses by 1 as well. That should also happen down here, because the number of guesses should go up. Okay? Then finally, the last line is let's display that. Into our label for the number dot text, we say number of guesses equals guesses. So that will display the number of guesses in our label. Okay? Let's try it. I'm going to guess 1 and 3. Too low, too high. So I'll guess 2 and 2. 2 guesses. Oh, look at that typo there. Too low, too high. So I'll guess 1 and 5. I got 1, but 5 is too high. Let me guess 4. Correct. I win. It took me 3 guesses to get the 2 numbers. It was 4 and 1. That's how it works. Okay? That's how it works. Everything I showed you guys, as I've said before, is in the notes. So in the notes, and it's highlighted in the notes, right? So here you can see in the notes, it outlines the code, it puts it there, and it explains it, how to get to the code. It has the first half of the code there. It talks about it on the side here, how this is an else if, as well as using a Boolean variable, which you may not have used before, okay? It then goes on to put the second piece of code, and it talks about how if you use copy-paste, which, by the way, is a very valuable tool as a programmer, copy-paste, but you got to be very precise about how you use it, okay? Then it continues on, and it uses and or, and it suggests that this is definitely something you want to use as a major hint for problem 3 and 4.